When students start studying theory of computation, a question that often comes up is, why do we have to know this? Compared to subjects like algorithms, data structures, machine learning to cryptography, theory of computation just seems less practical. But computer science is more than writing code, compiling code, fixing bugs in code, compiling again, and then finally going for a walk because now you have more bugs to fix. In fact, computer science is more than how your computer's processors and chips work. At its core, computer science is about one thing: problem solving. And this is where theory of computation really shines. Going beyond code and hardware, we try to better understand computing and answer this one question: what are the fundamental capabilities and limitations of computers? Can we actually solve every problem in this world through computing? We want to know this because knowing what a computer can or cannot do will help us solve problems more efficiently, especially since there are indeed problems in this world that a computer can never solve, no matter how much time we spend coming up with an algorithm. Here's an example. Let's say we want to write an automated test that checks if a program will eventually finish running and stop, or if it will continue to run forever. However, our automated test that we're going to write never actually runs the program, it just reads its lines of code. Do you think it is possible to test the code without actually executing it? If you have written automated tests before, you will likely say no. And your intuition is right. It's impossible. This is an essential problem in computer science known as the halting problem. In theory of computation, we mathematically prove that such problems can or cannot be solved using something called models of computation. A model of computation is an abstract representation of a machine, so it isn't the same kind of physical machine that we use every day, but like any of those machines, it takes in an input and computes an output, and we use these models to think about and solve problems in computing. A model of computation you might have heard of before is a Turing machine, developed by Alan Turing to prove how there are a lot of problems in this world that can never be solved through computing. And in order for us to get comfortable with the structure and mathematical reasoning of solving these problems, we will start the course by looking at much simpler models of computation first. And if there is any part of you that feels like mathematical proofs sound scary, or the thought of studying such theoretical and abstract material makes you nervous, remember that through patience and practice, you can get really, really good at it. Everyone gets better with practice. So I hope you have a little bit more context as to what theory of computation is, and like the other topics in computer science, it really is all about finding solutions to problems, even if we solve them with abstract machines.